All right, today we're going to be looking at some organic chemistry stuff and some molecules and how we name them. First up, we have alkanes. This is a simplest type of organic structure. It's just a chain of carbon atoms bonded together, single bonded. So as you can see here, what we have to do first here is count our carbons. We have 1, 2, 3, 4, 5. So we have 5 carbons. So we know that our root term is pent. And since they're all single bonds and it's an alkane, we have the ending ANE, and that is how we would name that structure right there. All right, moving on to our next page. We'll do something a little more in depth. We'll take a look and we'll go here. Make one more here. And so you're looking, as you can see, we always have to do is find our longest chain. So it would appear as though it would be right here. 1, 2, 3, 4, 5, 6, 7. I see. Well, I'm not going to get into this right now, but we will just make this one more. We'll make this 8, so it works out nice there. Let's see, when we look at this, we're going to go 1, 2, 3. So we have 8, that's our longest chain, so we know that our root word is oct. And now it is also an ane, so we can add our ending. But now we also have to take in consideration, we have these 2 branches here. So at our 3 carbon, we have a 1, 2 chain. So that is going to be simply ethyl. And the reason we have an ly ending is because it's just a constituent, which means it just breaks off the main chain. And we also have one here at 4. And here at 4, it's just a single, so we just have 1, so it's a meth. Now when we go to name this, it has to be in alphabetical order. So I actually have this backwards right as it is. If we were to look at naming this molecule, it would just be right here. Our ethyl comes first since it starts with an E, and that's on our 4, or our 3, so it's going to be 3 ethyl, 4, just 1, so it's a methyl, and taken to our longest chain, so it's just going to be octane. Alright, simple stuff, so we're moving on. Alkenes, again, very, very similar to the previous alkanes, except now we have a double bond. So if we were to draw something like this and have our bond there, we would always start at the beginning of your double bond. That's just a rule of thumb. So the way this molecule lends itself, we really don't even have to take in count to the 1. So really this is going to be, again, numbered it 1, 2, 3, 4, 4, so that we're looking at a root term of bute. And now it would be ANE if we were to have just a single bond, but we have this double bond we have to take into account here. So that's going to be ene is our ending here. Alright, so simple stuff. Take a look at some more. What happens when it's not at the beginning? Well, just draw this one out here. So now, we always want to start with the one closest to the branch. So we have this right here. So it's going to be 1, 2, so it would be 2, and that's just a methyl, 1, 2, 3, 4, 5, 7. So that's our longest chain is 7. So I'm just going to write this over here to the side. And remember, there's double bonds in here, so I'm just going to put this ene right here. And now we have double bonds at the 3 and the 5 carbon. So when we go to write this, we'll just simply write it 3, 5 heptene. Again, simple enough. Moving on. Alkenes. Again, as I'm sure you would have guessed, simply refer to compounds which there's a triple bond present. These end with YNE and form linear bonds. So these aren't really common when we look at most of our organic structures, but the thing that's very distinct about these, if I have a carbon and it's triple bonded to another carbon, this is going to be 180 degrees, right? So just something to keep in mind. So now if we were to have a structure that were to look like this, no, those lines aren't very straight at all. Again, we're going to label this. So this gets the lowest priority number. 1, 2, 3, 4, 5. So we have 5. So again, our root's going to be pent. And then since we have a triple bond present, it's going to be YNE. And the triple bond is starts at the 2. It's always where it starts, so we can just write this 2-pentene. Or just another way you could potentially write it would be 2. And sometimes, depending on what the book says, either is acceptable, just a personal preference. Moving on to amines. Amines are just a basic functional group, and the key characteristic of this molecule is nitrogen being bonded to a group with carbon. And we'll move on to our next slide to take a look at some of those. First up, we will just do a very simple one. Just have our regular carbon chain. And then now we're going to add our, I'll just put it right here. And this right here, this is the key that makes this molecule right here an amine. Right? So now let's take a look back at our chain, and same as always, we're going to look and see longest carbon chain, and we want to start numbering on the side that gives this the lowest number. So that'll be on the left side, and we'll go 1, 2, 3, 4, 5, 6, 7. So we know that our root is going to be hept. And now this is where we have to see which carbon our amine is coming off of. And so we see it's our 3. So it's just simply 3 amine. Right? All right, let's take a look at another one. What happens if we have and this is also getting into another slide. We're going to be talking about cyclose, but it's a fairly easy concept. We have right here, this is what we have called a ring. And so what if we have a amine group coming off there, and we'll just put that's good enough. Just a carbon chain coming off here. So what do? First, we have to look for order of precedence. Which one takes higher priority? In this case, it's going to be our amine. So this is where we're going to start our numbering. And we want to start numbering in the direction that'll give our next constituent the lowest number. So that's going to be down. 1, 2, 3, 4, 5, 6. And I haven't really gone over this yet, but since we have a ring, it's going to start with cyclo. That's going to be at our ending, and I really should move this over a little bit, give myself a little more room. Put that over here. And we have 6, so we're going to have this again. And then we're going to put this, and this isn't really necessary, but I just like to, 1 amine. And it's understood that it's at the 1, since if you didn't have anything else, it's just an understood. And now we're going to go to our constituent right here at number 3, and this is a 1, 2, 3. So we have the term propyl. So it'll be 3 propyl cyclohexamine, and that would be the name for this molecule right here. So moving on, amides. Amides are derived from carboxylic acid. It contains a double bonded oxygen and a nitrogen bonded to the same carbon. 2 examples. Here we go. We have our carboxylic acid, our carbon double bond our oxygen. Same over here, carbon double oxygen. And you can see the only difference here is that it's being replaced with our nitrogen group right here, our NH2. So it changes from carboxylic acid to amine. And simply, the ending, when we're going to look to name these, is just going to be simply amide. So let's go on our next slide, take a look. Let's see. Get rid of this. So now when we go to take a look at this, naming this group right here, what are we're going to want to start numbering so that this is the lowest constituent. And so actually these are in fact 2 different groups. This right here, we have our nitrogen group coming off one side of our double bonded oxygen. And so this has a name all on its own. So it's kind of be broken up into 2 different parts here. I'll just write out the first part. This is what we call an N-methyl. And the reason methyl being we only have 1 right here, 1 carbon, and this is going to have a second carbon here, but they're both in 2 different directions. So really what this term should be would be an dimethyl, since we have 2 carbons coming off. And then we look at our other side, which has just our carbon chain is 1, 2, 3, 4, 5. So now we're just going to put this here, 5, so that is our pent. And this whole molecule here is called an amide. So we just have our ending like this. And that would be how to name a structure such as that. Moving on. Alcohol. The main defining characteristic behind an alcohol is the attachment of an OH group directly to the carbon chain. So we'll just draw something simple like this. OH group right there. Alright, so just like everything else, now that we have our chain, we're going to number it. 1, 2, 3, 4, 5. And so, again, we have the pent, and now pentan. We are going to look at the ending. Now this isn't, since this has an alcohol, this is going to take precedence, so it's not going to be pentane, but now instead it is going to be pentanol.